Hello and welcome to Builders. Today we're excited to have Jakub Korczyc, Director of Spacecraft Engineering at ICEYE. ICEYE is leading the way in Earth observation with its advanced synthetic aperture radar satellite constellation, providing real-time monitoring for applications ranging from disaster response to national security. Their satellite data is transforming how organizations react to crises around the globe. Jakub, thanks so much for joining us today. How's it going?
Good. Hey, thanks for inviting me and happy to be here.
Lovely to have you with us. Let's start, shall we, by talking a little bit about your journey to ICEYE. What came before? You've been at ICEYE, I believe, in different roles for over a decade now. But what took you there? What happened before ICEYE?
Oh, what happened before ICEYE? I as you said, I joined ICEYE 11 years ago, and I pretty much joined straight out of university. Just before that, I did my bachelor in Warsaw in electronics, and later on in Stockholm, pretty much also in electronics. And I took some internships at CERN, the European Research for Nuclear Physics, and at ICEYE. So a small kind of internship endeavor with scientific organizations, and basically straight out of university joining this 10 people startup of ICEYE.
Fantastic, and been going been filling different positions, basically different roles. So going from strength to strength at ICEYE. But let's talk a little bit about ICEYE, shall we? And its mission and kind of impact as well. Could you give us a high-level overview of ICEYE's mission and how the data that you're gathering from space impacts life here on Earth?
Sure, of course. So basically, what we are doing at ICEYE is trying to improve life on Earth using data from space. And we do that by owning and operating world's largest constellation of synthetic aperture radar satellites. Those are satellites that goes around the globe and they take images of Earth. And what's maybe so special about the radar satellite is that they can deliver those images regardless of the time of the day. So they can do it at night, or they can do it through clouds. So regardless of the weathers, we can see through clouds. And what it enables to do is what we would call the persistent monitoring. So if you have some assets, some sites, some spot of interest, now you can actually monitor it regardless of the weather or time of the day. And before ICEYE came along, this capability did not exist. What I think we did is to kind of paint the picture. Back in the days, the satellites, owning satellite was let's say domain of governments and big kind of governmental institutions, and you would build 1-2 very expensive satellites that are size of a bus. They're very sophisticated, but there are only few of them that you own, and that means that if they go around the globe and if you have only few of them, you cannot revisit given area that often. So you take a picture of let's say a sea, and maybe the next picture you will take a few days later. So if you detect some boat, and then next time the satellite passes over that region in a few days, that boat might be well gone somewhere else. And what we kind of did in ICEYE is to set up, hey, maybe we can do those satellites, but significantly smaller without sacrificing much the quality of the images. And that was the premises those 10 years ago that we kind of started with. And turns out, yes, you can do it. You can make them smaller. You can make them low cost. So then instead of launching one big satellite, you launch a whole constellation of satellites that enables this kind of use cases.
Really, really interesting. And you mentioned it's this technology that's essentially being kind of built by ICEYE, the SAR, the synthetic aperture radar, that this is capable of essentially of capturing data 24/7 then, because unlike, what would the alternative, what was it before? It would have been more kind of optical technology. This wasn't kind of capable of seeing kind of in darkness or through clouds and everything like this, right? So this is essentially whatever the weather, whatever the time of day, you're able to capture this data and images essentially, right?
Yes, exactly. I think when we think about satellite images, people are used to Google Maps and
Yeah.
seeing those colored images. And if you open Google Maps and let's say scroll to the region that isn't that often image or that densely populated, you actually see clouds there.
Mm.
Um, so that's one technique, and it exists, and people still use it. But it can only image at certain time of the day, usually in the morning. So
Yep.
then, if you have something illegal or something you want to hide
Mm.
to do, then you just do it at night, and no,
Yeah.
no
Yeah.
satellite, no optical satellite can capture that. So that's the alternative, and those
Yeah.
systems
Yeah.
exist, and they're also being used.
Nice. And digging into the this radar kind of satellite data a little bit. Can you give us an example of how ICEYE's technology, the satellite technology here, has been used in recent disaster situations, like the flood mapping or wildlife monitoring, for example? Have been quite a few kind of weather disasters or kind of events in the news fairly recently, hasn't there?
Yes, yes, and I think we've been helping or trying to help in most of them. So one of the example that kind of lands close to home to me is the floodings in southern Poland that recently
Mm.
happened.
Mm.
There was a lot of rainfall and quite unusual, we say once in a millennia type of flooding.
Yeah.
And what ICEYE did at that moment, we activated our flood monitoring service. It's a service that we deliver to our clients,
Mhm.
and we would activate it for region of Poland, but also broader areas of Europe that kind of got affected at that moment. And what will happen is we will task our satellites to image the areas, and we will have people 24/7 analyzing those data and
Mm.
delivering reports, saying which areas were affected, basically extent of the flooding,
Yep.
with, let's say, down to a meter precision type of extent of the flooding. So you can very
Wow.
precisely see which villages are affected, which cities are affected, but also which bridges are
Mhm.
you can go through, and we would deliver those reports every few hours to crisis monitoring centers that would then coordinate deployment of help, basically first
Yeah, different.
responders.
Yeah, different resources. So governments can act, and I mean, particularly kind of governments and insurance companies, I assume, are kind of the end users of this data, right?
Yes, yes. I think that's disaster kind of response and helping with relief is one example. But of course, we have this kind of service that would provide that data
Mm.
to insurance companies, where basically instead of asking them to analyze the data and look on the SAR images, maybe they never heard on what the synthetic aperture radar satellite is, we
Yeah.
deliver them a report telling which buildings are flooded,
Hmm.
and with a confidence level what is the kind of flooding extent,
Got you.
and that allows them to kind of better sometimes they could even pay policyholders automatically,
Hmm.
just based on this kind of objective ground
Wow.
truth that we can capture from space, and that's better for them because they shorten their time of the event to the payment, but of course it
Yep.
helps people to start rebuilding quickly.
Yeah, exactly.
It
Yeah, go on.
I was like, it also enables parametric insurance. So instead of reacting on the claims, you can say that, hey, if there was a flooding event and the flood exceeded certain level, we do automatic payment. And that allows to kind of serve
Got you.
insurance to the regions that usually are not insurable, or there was hard to serve insurance to those. So kind of
Super.
this kind of source of truth from space enables to increase the coverage of insurance, for example.
Yeah, and also this kind of far more kind of efficient transfer or kind of transformation of meaningful data in this sense for your clients. But as far as I understand as well, ICEYE has a unique approach, I think you could say, to like embedded software for the satellites, right? Could you explain the role of embedded software in your operations and what makes it so unique and what makes it so essential?
Sure, sure. I think uh, I think the way I think about it, and maybe the approach is not that unique to your viewers, who I presume are mainly software engineers, are used to modern system. But if you think about satellites, what it used to be, and it still is, those are kind of big bespoke systems where once you write software once, you don't really change it.
Right.
And a kind of our approach and the new space approach that we are using is pretty much like with Tesla. So instead of buying one device that does one certain thing at the time when you get it, we can do over the air updates, and that allows us to experiment with the data collections,
Yep.
and unlock new modes of collection. So,
Yeah.
for example, we launch our satellites, and later on, when we kind of research it more, we were able to find out a new collection mode where we stare at a given spot for longer. And that allows us to kind of record the reflected signal from different angles and distinguish objects under the canopies of the trees, which was not the feature we built the satellite with, but we were able to update the software, let's say on the fly, while in space, and kind of enable new features. So maybe nowadays with the phones and every other devices, that's pretty common. And I think we and other players in the market on new space brought kind of that functionality, let's say, to satellite systems that was not so common.
Really, really interesting. So you're essentially allowing or enabling this kind of data processing directly in space, reduce latency, presumably here as well, and enabling real time decision making here on Earth, right? By using these systems.
Pretty much, yes.
Fantastic. And on the ground, obviously we're talking about the satellites and the kind of software underlying these up in space, but on the ground you develop software that also kind of optimizes the satellite's kind of use and improves image quality, right? Can you describe what that process looks like and the technology involved there?
It's yes. As we own and operate a big constellation of the satellites, of course we kind of run into a unique challenges or opportunities of kind of tasking this fleet. So one maybe interesting to your listener example would be, the satellite goes around Earth, and they would kind of take images at given spots, and later on, while they pass above a ground station, they need to downlink it. And we have a set of rules where some customers would really care that image is downlinked very quickly after it's acquired, because maybe they have some actionable items that they need to take, some actions they need to take based on that image. Some other customers might not care that much, and the image can wait. We also have multiple satellites, and we can choose which satellite takes a given area. And of course, interesting optimization challenge is how to optimize it, how to use that resources the best, of course. But the range of challenges on ground is quite broad. How we enable our customers to order those images, both through portal where they can sit and do it themselves in the web interface, but also using machine interface, so to integrate their systems into, or our system into their system. You can think that, to kind of make it very concrete and real, you can think about coast guards trying to monitor the waters around their country, let's say, but the radars only reach so far, so they can try to integrate our system, our images through the machine interface into their system, so they can see it as an extension of it. So there are many interesting, let's say, challenges that are not necessarily connected to space, but maybe they are unique because not many players are trying to do what we are trying to do. So I find it quite fascinating.
And these challenges, who are the people behind the challenges? Who are the people kind of dealing with these challenges that you're talking about? We're talking about the team and a little bit of the team at ICEYE, and also kind of recruitment here. What does your team look like?
We have 700 people globally, or around 700 people globally. We are located in 3 main offices in Spain, in Poland, and here in Helsinki. in Finland. And I would say it's a very broad cross section of the society at large. I lost count of nationalities after first 30 nationalities. I think it's kind of hard to find the missing allied nation out of the list of the nationalities at ICEYE. Let's say so. So we try to keep the team diverse because I'm engineer at heart, and the way I see it, it really helps us to take better engineering decisions once we have a multiple views and multiple approaches to the problem. So I think that we have a lot of specialities, kind of starting from because what we try to do, and the only way I believe we were able to achieve such a agile system is through a lot of vertical integration. So a lot of technology is designed by us. So we would, if you think about software, we'll start from writing a VHDL code. Even people argue if it's software or hardware, but we would write VHDL code. We would go through embedded drivers kind of software, then go through C, and all the way through all the systems into user interfaces and user experience specialists. So you kind of in one place gather a lot of specialists, and I think great things emerge once you get such a broad set of people from different backgrounds, but also different knowledge into one room.
Yeah, very, very well put. And obviously, it's very, very easy to think, your team would have been, if you hadn't kind of just spoken about the diversity and people diversity in systems as well, of course. But it's very kind of easy to think, of course, they're going to be hiring kind of space engineers, right? But obviously, you're not just hiring space engineers. But what kind of engineering background would you say, or do you find adds the most value to your team, especially when it comes to kind of software engineers?
Yes, I think so. Of course, we don't limit. We also hire space engineers, obviously.
Right. I would have expected so. Yeah,
but I don't think it's a majority of our engineers. I would actually think, and I was counting a bit. Maybe half of our engineering force is software engineers, one way or another. At the end of the day, if you think about any modern complex system, it's software defined because that's how you define its functionality, and you want it to be a software defined system, high performance, but software defined. So we of course hire many types of engineering. I would have an easier time listing maybe types of engineering we rarely hire than those that we hire. But of course, there are a few kind of features or traits we look into engineers, and those are kind of maybe more generic, but we do look into people that are problem solvers, that kind of know how to collaborate and knowledge share, because that's kind of very important for us as we do something that never been done before. We need to have that approach, and also people that are curious and want to learn. So even though they come without a space background, we try to teach people and have them understand at least the basics of how the satellite works and what's the kind of type of system we're building and what we are trying to optimize for, which of course changes all the time. So
exactly, it can't be easy, but I mean, I think if you have that kind of diverse skill set within the team, you're talking about obviously these space challenges, for example, but a lot of the kind of potential kind of underlying solutions or what you're working on is kind of handling large data volumes and to optimize your processes, right, and improving overall kind of performance and adaptability. So there's a lot of kind of transferable skills, is what I'm saying, right, across different industries.
Pretty much. I think at the end of the day, the challenges we face building a complex Earth observation device, it's very or system is very similar that at the end of the day you would face if you build any other complex system. There's a lot of data. You need to analyze that data. You need to handle it. You need to write. You need to deploy the software. You need to make sure you don't mess up the deployment. You need to handle infrastructure. All of those kind of engineering done right, it's kind of adds up to a great system altogether. So
Yep.
definitely we mainly search for the good engineers, and as a secondary we search for people that are excited about space, but
Yep.
they need
That
to
makes
be.
sense. And are these type of people, are these profiles easy to come by?
I would. The short answer is no. I believe that the biggest challenge. I mean, let's be honest. The biggest value in ICEYE and the only reason why we managed to achieve what we achieve is people. Let's say the team building and getting the right people and creating the right environment. That's the most of the value that really exists in ICEYE and that I would believe exists in any company. So definitely hiring is a challenge for us. That's why we kind of try to reach globally and don't limit ourselves only for certain areas.
And when it comes to kind of hiring globally, you mentioned it was 700 and something employees at the moment. Where are you kind of distributed globally then? Offices in certain countries, but you're kind of have a kind of a team working in a distributed manner, kind of remotely, or how does it? What's the setup?
It's a hybrid setup. So we have strong offices, and there's a lot of engineering happening. As I said, in Helsinki, in Poland, in US, and in Spain right now, and we also have a kind of engineers doing remotely. So it's hybrid. We try to build a critical mass in the hubs, so the collaboration can happen. But we also look into how we can enable our kind of remote team members that very often bring a very unusual or kind of specialized skill set to the team to also feel integrated. So of course it's a challenge. I think kind of starting in Finland, we always knew that just the population we can reach locally, just because of how many people are in Finland, isn't that great. So from the very beginning, we've been operating in this mode. To give an example, we know that people very often need to move somewhere in order to kind of be here. So we have policies that would help that. We would have what we call significant other policies. So we would pay people tickets to fly to see their significant other once a month. So we can support that kind of relationships or relationship with their parents that are far away and they don't get to see very often. So those are kind of few unique things that we do to
really nice,
to kind of make people life easier.
These are good good ways of dealing with these matters. But how do you overcome kind of challenges that you might encounter when kind of onboarding engineers? I mean, you might be onboarding engineers that are not familiar with the space industry, for example, and that's okay. But particularly with these kind of this remote or kind of distributed setup, how do you encounter these kind of challenges when it comes to onboarding them, and how do you deal with them?
It's hard for me to kind of judge if the challenges we see are more than in other companies. In that sense, we of course put a lot of attention into kind of onboarding. And I would even say we put more attention in selecting the right type of people at the interview processes. We hope that we get curious people that want to kind of act as one type of a thing. So I don't think we have especially high challenges on it. We do run knowledge sharing sessions where we share that knowledge, sometimes around space, sometimes around AWS infrastructure. For me, as a space engineer, kind of AWS infrastructure is, as I guess, equally fascinating as as the space topic for the infrastructure people. So we kind of use it as our strength. Let's say, and we always been operating in that mode. So I wouldn't say we have necessarily challenges onboarding people. We do pay a lot of attention into culture. We kind of very early on realized that, hey, what makes ICEYE successful, or what made it successful through the kind of startup phase where we built that very first miniature star satellite, and we said, okay, let's codify it. Let's make sure that it kind of stays there, and then we still promote this kind of culture of being curious, acting as one, and having fun in everything you do.
Yeah, no, it's really, really well put. Again, I think yeah, we see as well among our clients, you really can't kind of underestimate the importance of that kind of the cultural fit, the curiosity, as you said, them being really interested in what they're going to be working on, right? Because it can be ostensibly, like, on the face of it, you can. It's a little bit easier to maybe match on like a hard skill or kind of hard skill set, you could say. But then these kind of other aspects, the kind of softer skills, are so important as well. So I can really agree with what you're saying.
Correct, and especially that. Uh, Again, what we do is such a complex systems that we rarely find somebody who has such a broad knowledge, and even if they do, we try to innovate, try to do something that has never been done before.
Yep.
So they're almost by definition, the hard skill is not everything. There is ability to logic think, to draw conclusions, to just do good engineering, but also collaboration is most critical, because no great achievement is done alone in human
No.
history.
No. Very well said. But you operate in a sector that's obviously, constantly seeking the best tech talent, right? How do you ensure that you can retain your current team and keep sourcing with such kind of high standards?
Yeah. Yes. Give me a second. I kind of took a bit of note.
Mm.
So, in sourcing, as kind of as we touch, we try to reach out globally and support people moving, and support them kind of moving to one of the test hubs.
Yep.
And I think retaining people is quite interesting topic. I think we have a company that is trying to do something or it's doing something that has a meaningful impact on the world, and I would say on the whole world, and that impact is positive.
Yep.
And so that's a company with vision, and with impact, and with a lot of growth opportunity. I would say we are at the beginning of the road. So we kind of get that one going for us, and that's inspiring. That inspires me. But of course, that's maybe I would say a necessary condition, but not sufficient to
Right.
retaining great talent. I think that the other side of it is kind of creating environment where people can be appreciated, can feel safe to experiment, safe to learn, and also kind of caring about people career path and development, to kind of maybe give you, and I'm people manager, and we always tell our people managers that, hey, it's their job to care about the career path of their people. Maybe I give an example. When I talk with my direct reportees on the development discussions, I tell them that, hey, I'm here to kind of support them in the career path and in the professional development, even if that development at one moment will kind of take them outside of ICEYE. That's okay. I'm being paid here to kind of help you grow yourself and help you figure out how to do that. So I believe you just need to select the great people and create them a really environment in which they can thrive, and they will stay.
Yeah, very well put. Yeah, some good tips there for retaining the top talent, but also really focusing on them. But in terms of product development and the applications of the products that you're building, you design and sell satellites, I think, as well. Can you walk us through that process, like from ideation or from conception to the final product? What's the typical timeline here, for example?
Yeah, I think the timelines will span within a year or 2 years, depend on the project. Of course, the kind of software projects that would be, hey, let's enable another collection mode. That will be shorter. I think we will kind of go through conception to experimentation within a year, and that part
it seems
is
to me this seems
sorry,
like so short. Obviously, I'm not so kind of um, in the know regarding these systems, but it seems like a year, or even a year to 2 years, seems like such a short timeline for this kind of product. I mean, because finally you're essentially deploying these satellites into orbit, and there must be so much work that goes into there, the requirements, the kind of the rigorous testing along the way. I mean, this is a really small timeline. What are the kind of size of the teams that are working on these products as well?
I think per kind of feature, I would say we have 10, 15 people kind of maybe assemble in the project. So of
Right.
course those features that are kind of software driven, they are shorter. If we want to optimize something or enable the mode, maybe
Yeah.
if we think about hardware, I would say it's 2 years to kind of from conception going through requirements and we introduce a kind of a gated stages, what we call design to build, where we kind of at least make sure that we reach out to other experts once you design something, let's say
Mm.
a gimbal antenna to point to the station so we can take the image and downlink it at the same time. The process that we are introducing now and using would kind of have those gates that we at least reach out to
Hmm.
other teams that are not the project team and kind of discuss and check, hey, is it passing the requirements? Is it passing the test? Um, and of course, what kind of enables us to do that is the fact that we own our own fleet. So we can kind
Right.
of add a new feature to one of our satellites. We would not do that for the customer satellites, but we'll add it to our own satellite.
Hmm.
And that allows us to kind of take testing kind of approach and test it in orbit. So if when those satellites costed billions, now you will
Mm.
need to go through very rigorous testing on ground to recreate the vacuum,
Yep.
recreate the cold temperature of space, and all this kind of environment. And yet you couldn't recreate everything, and you couldn't kind of debug all those emerged kind of properties of a complex systems. So having ability to kind of add it to on our satellites, maybe as a secondary system, as a redundant system, that kind of allows us to test it quicker and just not be limited by this kind of space environment
Hmm.
restrictions that been kind of there before. Like if you build a new car, you can build it in a year and you can just drive it in the truck.
Right.
You were not able to do that with the star satellites before we came, but now we
Mm.
can find the satellite, add that features, test it on orbit, and kind of based on the telemetry data, know what we need to fix, and
Mhm.
and maybe do it 2-3 times before we start offering to the customer, and it's kind of hashed out all the problems.
Super interesting. And talking about the kind of applications where these products can be, yeah, applied. Essentially, we've been talking about, natural disasters and flooding and stuff like this, but these products can also kind of play a role in national security and stuff like this, right? For kind of sea and border monitoring, for example. Can you expand on how ICEYE's technology enhances security applications?
Uh, yes, of course, it's a hot topic recently, especially in Europe. I can maybe
Mm.
add so there are many applications where you can kind of use this type of real time or near real time data to monitor what is happening at the borders. Maybe I can add one example that is kind of quite graphical to understand in the ship monitoring or in the dark vessel,
Mm.
what we will call dark vessel detection. So you have those ships that normally have this system that is called AIS, that they will broadcast their location.
Hmm.
And when they want to do something illegal, either illegal fishing or vessel to vessel cargo transport, so they can
Hmm.
obscure where the cargo came from and maybe evade sanctions or actually aid human trafficking, they will turn off
Mm.
that system. They will meet at deep sea where there's actually, as humanity, we don't really have eyes other than satellite at deep sea,
Hmm. Hmm.
and actually perform those illegal activities, either transfer cargo or do fishing.
Yep.
And back in the days when there was a boat illegal fishing, there's one satellite passing once a week. They would just not go there that day. But
Exactly. Yeah.
nowadays that we
A
have
way to get around it.
exactly,
Right.
exactly. But now that we have a satellites, we can identify those vessels, check which ones with our partner have the AIS turned off, and provide that information to our users.
Really nice. So you're fighting crime as well, helping governments and organizations fight crime at least. Super. With this satellite technology as well, you're obviously capturing this data and in space, turning it into these kind of actionable insights on the ground. What's involved in that data kind of transformation process? How does ICEYE's kind of analytics enable? your kind of clients to make these informed decisions? How does that transformation process work?
So you're asking how we kind of get the information from the data, right? Or how the data reaches from
first how the data kind of obviously reaches, and then kind of how that kind of it results in these kind of actionable insights.
Yeah, so I can maybe kind of give an example of flood monitoring. And kind of follow a bit, follow the 1 and 0 of the data through its journey. So we basically monitor weather. We actually have a hired meteorologist that would kind of help us predict that, hey, this is let's say area of Japan that is going to be hit by a storm or stormy floody weather. So we'll go ahead and task the acquisition of the areas before the event, so we kind of know what the baseline is. And once the event is progressing, we'll take the images once the kind of water is flooding. And of course, what this taking images for us is kind of going into very technicalities, how the radar works. We'll generate the digital pulses. We'll send them as a radio wave. They will travel 600 kilometers to Earth. They will bounce back off the water surface and the houses. They will travel back. We will record them. We'll using FPGAs. We will store them on SSDs, and then once the satellite is passing over a ground station, we will download that data to our kind of capture system. In there, it will happily go to a S3 bucket in the Amazon cloud, where we will then kind of process it into image. And at that moment, we will deliver that two-dimensional image or set of those images to our kind of flood monitoring team that would kind of merge and fuse that data with other type of data. So, for example, we will use the digital terrain data, so we know where are highs, where are lows, and how the water would kind of flow, and we know from the surface of it what the extent was. So then we can kind of build that model of, hey, those houses were flooded to that level with that degree of confidentiality, and we will then deliver that data as a form of report into to our kind of insurance customer. Sometimes as just Excel with rows by saying this house, this many centimeters. Sometimes in more sophisticated manner as whatever kind of our customers can handle. But we on the commercial side, we don't want them to be synthetic aperture radar data experts to be able to use it.
Of course.
Pretty much in the same way you don't really need to know how GPS works to order your Uber.
Right. No, exactly. Yeah. That's a good comparison. But and how many kind of ground stations are there that are kind of enable you once you've kind of retrieved this information back? Once you've kind of sent that, and you've got the pulse and it sends back. How many, out of interest, how many kind of ground stations are there that you kind of downlink?
Oh man, like maybe 20. I think the two main ones is there is a Svalbard on North Pole and Troll on South. Also, there will be two biggest ones that the satellite pass every time because they're in the polar orbits. But there will be way more from various providers kind of located across the globe. And we developed what we called Connect, which is a kind of API layer that allows our customers to connect to any of those stations without kind of knowing, okay, this is KSAT or this is another company, kind of abstracting that level. So Earth is quite densely, let's say, sprinkled with ground stations wherever you have land. Basically nowadays, if you can only kind of tie them together and use as a one system, which is something that we discovered for ourselves, that hey, suddenly we have such a problem, and maybe people didn't have such a problems before, so we developed this system, and now we kind of offer it to our customer as well.
Super. And look into the future a little bit. Considering all these kind of rapid advancements and that we've been talking about a little bit, and the kind of technologies that ICEYE is building and the innovation that you guys are working with, where do you see ICEYE's satellite technology and the kind of embedded software evolving over the next 5 to 10 years, for example?
I think where all Earth observation is going is pretty much the same route as GPS went, through military system with sophisticated users to very few kind of sophisticated systems that uses it. Then maybe users that understand how to use it as well, to really applications where everybody will be able to, on their phone or their virtual extended reality glasses, able to kind of access this type of data without even knowing it comes from space. Of course, I don't know what the future brings, but one graphical example is that you can drive to your favorite supermarket or to the city center, and maybe there is a satellite passing by, or a high altitude platform kind of circling above the city and telling you, hey, there is a free spot in there, turn right next street, or
It'd be so nice.
or hey, this spot is a parking spot, but nobody been parking there. Maybe you are getting a fine if you try to park there. This type of information that you don't even know it comes from space, but you can use it, and I think that's really where the Earth observation is going over next decade, maybe.
There's some really interesting applications there. It would save me personally a bit of money on these kind of parking fines, I think. So I could be an end user here for sure. But super. But you're rounding off a little bit here. Finally, for those inspired by like ICEYE's work here, what advice would you give to engineers who might not have a space background, of course, but are interested in joining the industry and joining ICEYE?
Yeah. I think I have two advices. The short one is apply. Check our webpage. We always search for a great talent. Maybe kind of more generic, longer answer is that I think many skills and kind of problem solving abilities are transferable. So whenever you kind of interview for a position that you kind of maybe it's outside of your industry directly, or especially if you transition from academia, I know that's usually the kind of harder transition from academia to industry is to look for transferable skills and kind of examples where kind of collaboration and problem solving and owning the problem was something that you kind of demonstrated. Maybe that's kind of would be my advice for people seeking to kind of jump the industry or jump the career. It's very much doable, and people do that more often than one would think, I would say. Right. It seems like people don't do that because you live in your bubble of specific industry or in academia, and you don't think that happens, but I see it every week in ICEYE, and even within the organization, people change the boundaries. So even joining the organization on the position that maybe is not exactly kind of matched to what you want to do is also one way to kind of then figure out, okay, how the organization looks like, what are the skills I need to learn to then switch to another type of job, and people do that, and we support that. One kind of perk in ICEYE is that since we have so many specialties, the kind of internal mobility, it's a thing, and we use it to our advantage, and makes people, of course, happy. I myself went from being electronic engineer purely to then do a bit of system engineering, propulsion, orbital dynamics, and of course nowadays for kind of more people focus and purely people management side. So I enjoy my journey, and then I advise other people to also kind of and embrace the unknown maybe a bit.
Yeah. No, you're the inspiration here. Like I mentioned in the beginning, you've obviously kind of had many different roles at ICEYE since joining, and I think it's a really nice approach that ICEYE take here in terms of, like, people can get that foot in. It's that kind of initial foot in and working on something and realizing that there are vast opportunities and potential career paths at a company. I think this is a really nice approach. But yeah, I think that just about rounds us off. Is there anything you'd like to add, Jakub?
I don't think so. Thank you for inviting me, and for this opportunity to chat a bit about ICEYE and our approach to recruitment and our technology. I can speak about it for hours and hours to come, but I'm mindful of time here. So thank you very much.
Indeed. No, thank you. Thank you so much for sharing insights. Yeah, I think the work you're doing is kind of, well, it's groundbreaking. It's really, really interesting, and so interesting and inspiring to kind of hear how it's impacting life here on Earth. There's so much going on above our heads that we don't really, take any time to think about, right? So yeah, good work going on, and keep it up. To our listeners, we hope you've enjoyed this look into ICEYE's innovative world. And until next time on Builders, keep on innovating and keep on building. We'll see you soon.